Hi everyone, my name is Aldo Buki, and my demo is going to be a little less fun, but hopefully more useful for our day-to-day work. So I am the boring guy here. So today I'm going to talk about the API modeling framework, and even though I'm going to be giving the talk, all the credit goes to Antonio, who is the engineer that created and built it and programmed it, and he was teaching me how to show it. I wish he could be here, but he's in London and he's probably sleeping at this point, or partying, who knows. So the API modeling framework is a new open source project that we are releasing. You can find it on GitHub if you go to raml.org API modeling framework. And it is a set of tools and features that let developers work with APIs. So I'm going to go over the features, but it's important to understand right now that it's not a specific thing, it's a framework. It has a lot of different functionalities and they all come together and make sense, but you need to understand what they do. Who here has used RAML? Okay, 2 people, 3, of course, we created RAML. Who here has used Swagger? Who here has used web services descriptions? Or some sort of interface description? Okay, who uses APIs? Sorry, this is APIs and IPAs? Okay, and the guys that don't use APIs, what are you doing here? Right, so who's not using APIs and is here? Because you can't drink beer. You're breaking the rules. Anyway, so this is to work with APIs, and specifically with RAML and Swagger and OAS, sorry. Swagger is now named OAS descriptions. And what it gives you is, it is this kind of, it's a client-side tool and a server, and it lets you understand the API, so it loads RAMLs and OAS files, and it gives you a lot of features on top of that. It analyzes them, it lets you transform from one to another. The way it's built, or the problem it's trying to solve first is, the first problem is, if you start using web APIs, you're gonna find yourself dealing with a variety of different description formats. So right now, OAS and RAML are the most popular. There are others coming. And sometimes you need to transform from one to another, or you need to generate code. So the idea here is that AMF gives you like a supermodel, and you can transform from each of these formats into the supermodel and then go back. That's the main idea. So you have the specifications. This is RAML and this is OpenAPI. You parse them, you get the document graph, which is like the compilation units and all the different files with the schemas. And then you can also process that and you get like a fully processed domain graph where all the services are represented. So all these things live together in AMF. So you get parsing for all these different formats. You can parse and generate, so you can translate. You can also query the content of these files, but when it's just one file, that's not very useful. But if you have 100 different descriptions, imagine, so if somebody here worked with UDDI registry or some sort of registry for interfaces for web services, at some point you had so many that you started building tools on top to find things. Apparently nobody here is as old as me. So did anybody do that ever? I'm talking to like a different generation here. We're the only guys that lived through this. So we are an enterprise software company. That's important for you to understand. We deal with technology that is not on the cutting edge, but we deal with huge amounts of it and to a large complexity. So we need to tackle these problems from a different point of view. We need to build very robust tools that scale and that a lot of people can work with it. So this is not relevant. I'm going to skip it. So what is AMF? If you've ever used RAML or Swagger, right, you know that there are files, and these files contain the API description. So here's an API description. It has a title. This is the World Music API, and then down here it's going to start listing the different services at some point. So here, for example, it returns a list of songs, and you have ways of specifying the security that's applied to this endpoint and the different shapes of data that it returns. So if you were writing a RAML or an OAS API spec, you would end up with a lot of files. So the first thing you can do here is you can take one of those projects and you can pull it into the API modeling framework. And you can jump from one format to another. So I'm looking at the same API description in OpenAPI and in RAML. And if I change it over here, so let's say, is that a question? Oh yeah, yeah. Yeah. Do you think that that's like a problem that you have or everybody's having? Yeah. Okay. No, I get it. So on here on the left pane, you have a list of the files. This is probably a little small. Let me bring it up. Right. So I have the root RAML here. So if anybody worked with RAML, you would know what this is. And this is the description of the API. So on the right, you have the content of that file. This is like a text editor, right? And you can see that the title is described here. And then if you go down, you get the different services. If you were hitting this API, let's say you're hitting the GitHub API, there's a documentation. This is the documentation in RAML format. There's more than one format. There's RAML, there's OpenAPI, and a few others. And this tool lets you jump from one to the other without losing information. So if you're dealing with, let's say, an OpenAPI specification, and you have tooling that understands RAML, you can use this to move from one to the other. And you can edit this. Let me find the title. Where's the title? Here. Here. I'm going to edit the title. I don't know if this is going to work, but let's see if I can edit the title on the OpenAPI side. And of course it didn't. Anyway, that's working on some version of it. And there's another model that's a more general model. You can also view this as a graph. So in a way, this is like an IDE for API specifications. Yeah. Actually, I think I just have to press a button somewhere. But so you can do that. The other thing you can do is if you were loading a whole bunch of APIs, which our customers do all the time, you can start querying that set of APIs for things. Let's say you want to find out all the methods that return a certain error code because you want to eliminate it, but you have no idea who across the organization is using that. We give you this interface where you can write a query. This is a graph query language called Sparkle, and you can query the metadata. So all the files have been exploited into a graph, and you can start querying them. So this is actually pretty useful if you're working with this every day. If you're not, it will not make any much sense. But I guess that's true for everything, right? You can also, so if you look here, you have the main file, which imports all these other files. You can say, you know, I don't care, combine everything and give me the resolved model. Again, this is, if you were, I need somebody who uses this so they can be excited about it. I guess you guys are not using it. I'm going to show you something that's going to be exciting, though, that you will understand anyway. So you have all these features that you would expect from an IDE, right? All these features that we're showing you right now don't really exist in the API specification world. So this is a first in that sense. You would come to expect this from a Java IDE, right? That you have a way of looking at all the compilation units, and you have, you know, IntelliJ, you have some sort of index. Well, those things haven't been built for these technologies, and there's a spec war, or there has sort of a spec war, where you have to choose different technologies. In this case, you can combine them all, which is very useful because normally in a large organization, you don't really control what the different teams are doing, so you end up with a sprawl of technologies, which is bad when you're using different programming languages, but when they're interfaces, it's even worse, because the idea of an interface is to be common. The other thing that it has, well, it has a very advanced diff tool. So if you change, let me copy paste. I have an API on the left, and I'm going to copy the same API on the right, and I'm going to tell the tool to give me a diff. It tells me, well, there's no difference. I'm going to change the version, and it detected one difference. And I can look at the report, and the report is obviously telling me, well, there's an addition here somewhere, and I can start clicking and find it. So this could be feeding an ID. But what's more important about this is that if I make a change that's not relevant, let's say that I'm just going to move this line around, and I diff it, It's identical. So if you were doing this with GitHub, that would be a difference, right? There was somebody removed a line and they added something. But let's say that somebody changed an API and then you have another app that depends on this API, that wouldn't be relevant for the other app. That a line moved up or down, that doesn't matter. But if a method changes or if a payload changes, you would like to be notified. So there's a lot of work that has gone here into being able to understand the differences from a structural point of view and every different type of difference. This is important for code generation, for example, or if you want to have different teams depending on each other and prevent them from screwing up the other team, right? Oh, I just removed this field. I have no idea who's using it. In this tool, you can actually search for that. You can say, who is depending on the name field of this type? And there's this other guy in China that's using it. And if you change it, an alarm is going to set off, and you'll get notified. In order to do that, there's a lot of magic going on, but there's this general model. Well, it works with OpenAPI and RAML, whatever you can encode in OpenAPI and RAML, which is REST and some more, right? You can just write RPC. You can say, everybody do posts, and we're going to just name the paths are going to be the names of the functions, and so whatever you model there you can apply this to whatever you model on these technologies. Now, there's this internal model that we convert everything to, and then there's an analysis that goes on. So for example, instead of looking at the lines or the syntax that defines the method, we look at the actual things, right? The parameters, and there's an entity hash that's created for that. And so there's a very strong foundation to the way in which the diffs are detected, and the formal definition of what a difference is can also be understood and changed. So now I'm going to show you something cool that I think you guys will appreciate, even if you're not using RAML or Swagger or anything. In the version everything that I've shown you is out there when the open source version. There's a command line, and you can do all these things. People here are using it to do the translations. They're using it for schema validation. Forgot to show you this one. It also has support for the different types of schemas, right? So we have JSON schema and RAML type, and you can have data. This is a JSON payload. This is a JSON schema, and you can see in real time whether the payload is valid according to the schema. So here it says that the minimum age has to be 77. I can change it, and I can say, no, I want it to be 4. And all of a sudden, the error that was here before, it was telling me value is not greater than 77. It goes away. This is very obvious, but the nice thing is it works with RAML type and JSON schema. That means that somebody, Antonio actually, did all the work of formalizing these things and then understanding the mappings. If you use OAS, you're going to realize that there's a lot of that goes into the specification that's underspecified. So being in the process of doing this, we had to strengthen a lot of things in order to be able to automatically detect stuff. Okay, so here's something that you guys will appreciate. I have a development version of this thing right here, and I loaded a banking API, a RAML API for a bank, and it has let me see if I can find it somewhere. Yeah, I'm going to show you the API. Give me a sec. It is. Yeah, well, you guys don't need to see my command line. I type really slow when I have a mic here. Antonio and banking pre-demo. Okay. So we have a banking API that looks something like this. Oh, come on. How to make this grow? There you go. It is a normal REST API. It has some types like the customer data, bank account data, blah, blah, blah. It has an endpoint /customer. So imagine the GitHub API, right? This is modeled pretty much on the GitHub API. So customers and then the ID. The way you call this API is by saying get, and you give it the HTTP request, and you get the data back. But what if you could run a graph query on top of this thing, and it would understand how to make sense of it? So let's say that you wanna get the customers, and you wanna get the data, but you wanna make the explicit call to the endpoint. You just wanna write a query, like a SQL query, and you wanna have something smart that figures out how to make the invocations for you. That is what I'm going to show you here. So this guy right here, this is a query. It's kind of a GraphQL query language, but more like JSON. And what I'm saying is, give me everything that has an ID. An ID, I put it in the variable customer. Give me the given name, the surname, the gender, and the birth date. And just by looking at the API, at the description of the API, given that the API is following some conventions, this query can be answered. So this is an approach that lets you, who here has used GraphQL? And who here has used a graph query, a general graph query engine like Neo4j or Sparkle? Or SQL? Who here has used SQL? Cool, right? So, okay, SQL lets you express your query without having to tell the engine, hey, go into that table, pull this out, read that index, filter it here, join it in memory. You just say, I want this, and filter here, right? What if you could do the same for APIs? That's what we're trying to do here. And it's really useful when you have one API, but it starts getting more and more useful when you have a combination of APIs. So you have 3 APIs that talk about domain. You have your business split into different APIs. And you know that you want all the properties of a customer, but you don't know where they are. So you could write a query and then let this thing analyze the API, the RAMLs and the OAS specifications, and understand how to make a plan and then start killing the APIs. Yes?
Do interjoins from 2 different APIs to, like, for instance, if you had 2 different shopping carts and you wanted to know what your total sales were in both carts, could you pull them in the same
Yeah.
query?
So what you can do will depend on a variety of things, but the way we're building this is very experimental, by the way. This is something that it doesn't exist anywhere, and I think that the industry is going there. I mean, a lot of people are looking at GraphQL and they realize. Do you barely need the microphone? No. People are looking at the GraphQL, especially on the consumer side, and they're realizing, well, this is so much easier than to be able to go and read the documentation. I just write what I want. I want the customer, I want the name, I want the address, and I want this. Give me that payload. But not everybody is going to implement GraphQL. So we're coming with this approach that lets you take APIs that you already have, add some annotations, and start enabling from the consumer side this experience where you just write a query. To answer your question, the kinds of queries that you can run will depend on the APIs that are on the APIs, and will depend on the metadata that we have access to.
Why wouldn't you just put all your data into a data lake on Amazon S3 and have Looker query the data for you?
I mean, if you can do that, then definitely do that. But
do you think
if the data changes,
is it cheaper to do it this way, or why would you do it this way rather than that way?
So it caters for different.
Because that's a traditional way of doing business intelligence, right? You put it into a data lake and you run queries on data lakes.
Yeah.
So I'll jump in here. Sorry, look, so for the it's very expensive. There's data gravity, right? It's very expensive to move data around. So, but I suggest discussions of the data lakes and stuff. Happy to talk more about it. All those. Sure, all tools.
And if the data changes, or maybe you don't have access to the data, maybe you can just query one thing at a time. So that's what we see more and more is that our customers don't really own the data. You cannot look into the app, take the database and dump it. You just have access to an API with some terms of service, and you can only hit it 20 times. And you still want to run a query because you want to do that. You want to join, and you want to have a customer 360 view on top of 5 APIs, 2 databases, and this and that. So that's what we.
So, for instance, if you're trying to query data from 2 different websites from 2 different companies, you're trying to grab that data and combine it into a single view. You can do it with your API without actually having to own all the data.
Yes. You can, as long as what you're asking is not impossible. So, for example, here's where this thing starts getting to, or
in doing this, we realize, oh, we're getting into new terrain here, because you write a query, and the query says, count all the users of GitHub that use this language. GitHub doesn't give you that in this API. Like, there's no way of doing it. You would need to download all the users, download all the repos, and then do the count. Which of course you can. When you're using the API, it's pretty obvious. Like, no, I can't do that. Maybe I'll call them, ask them to create that for me. But when you're writing the query, it's a one-liner. Select, count, language for user, repo language, right? But in reality, it cannot be done. So the query editor and the engine has to be smart enough to tell you, hey, what you're trying to do is actually not possible. Here are some workarounds. Now, the interesting thing is that the amount of code that people write just to combine data from different APIs is huge. If you look at most of the integration, I'm sure you guys write, when you're writing a normal application, you're integrating the Facebook API, 3 more document processing APIs, or an image recognition API, and so you have to learn each one. You have to then write code, which whatever drivers or whatever technology they're using, so you have to download those things, and then you have to understand how you're going to call them in which order. What if you could just say, select, the user, what the password is this, and then with that variable get this here, and without having to write the code, just a query, as if it was all in one spot. So that's future, like future. We'll be talking more about this in API world soon, and showing some cooler demos, where it also works with GraphQL. So I told you this one was going to be more boring than Jess, but yeah, question.
When you said that you could add multiple API specs and query across them, is there a way, or do you guys have any plans to show a trace of the heterogeneity or the how fragmented your information is across different APIs, so you can start to minimalize your for example your APIs and say, oh, I'm getting this information from 6 different APIs where it really should be 1 or it should be 2. Let me see if it's we move to trace it.
I'll show you later. I have a demo here that does just that. That it kind of gives you a trace of what happened. So yeah, we're gonna do that. And we have to do that even before you run the query. We have to tell you, like, what you're trying to do is not possible. And that doesn't really happen in SQL, right? You can do a SQL explain, and then you can read it, and you can say, oh, it's not a good idea. But you never run into something that's just not possible. It maybe costs a lot, but in here so this is like a new space. It's really interesting. So if anybody here likes to write query engines and likes logic and weird stuff, you can join us, because we're having fun with this. That's it, huh? Sorry. Last question.
So if you have, like in this case where you're talking about customers that are in 2 different systems, say, 2 different CRMs, let's say, and you want to query across both of them using one query here, and then translating that into 2 different APIs, you have to map and say this customer is the same as this customer over here. Where is that map stored? Or do you have to actually enforce a naming convention across the specs?
So in some cases, you just need the API descriptions. In others, you need like a third source of metadata, right? Annotations that apply to both. That is something that we're calling like domain repository or something. It's a new concept. It's like this layer that's on top of all your systems that gives you extra information and tells you these 2 classes are equivalent, these 2 properties mean the same. If you have an ID here, this method can give you the ID on the other namespace. All those things could be plugged into this engine, but the result in the end is you get this graph.
You call it a registry like in Windows, right? Registry.
Yeah, you can give it any name at this point. So we're not naming things.
Can you give 2 API specifications in different formats?
To what extent? Like what we do that?
Just like if I want to change the description, I want that like what would tell me, like can I put 2 different formats? Like let's say one for animal and one's
we haven't done that yet, but you could just grab it, copy paste it here, change the format.
Yeah.
I mean, it's a mechanical thing. You probably need to correct some stuff there.
Yeah.
But since you have the equivalents, it's pretty easy to jump into this group. Okay, guys. Thank you all.